speak into that?
Yeah.
All right.
So we'll mic you up.
Script push over. Yeah, let me just get projecting. Oh my god, did I just accidentally delete my first slide? There. Slideshow.
No. All right, this is
Maybe.
armed. And
There we go.
Yep.
Okay.
Looks good.
All right.
That.
So just talking to this?
Just clip it on like right here, and it should be good.
Maybe.
Should be good.
Am I good? Awesome. Cool. Okay. So I went through a couple of name changes for this. We started off with Windows is the worst. And then how I bricked 10 VMs. And eventually settled on the adventures of Colonel Sanders. Now, a little bit of background on how many people here either assisted with or participated in ISTS? Show of hands. Cool. So this is fine, right? Everybody got really familiar with that background. Okay? So this is the story of how the Colonel Sanders malware came about, whose name is actually leech.dll. So we'll talk a little bit about that and how I developed this down to some of the screenshots, because it was a really, really interesting problem. So some background, I did Red Team for ISTS last year as well, ISTS 16 in Feb of 18. I was brought in on Friday because I happened to see a bunch of people I knew hanging out in a room coding that are alumni. I'm like, oh, what are you guys doing? I'm like, oh yeah, we're here for ISTS doing Red Team. Apparently they just added phones. I'm like, I can help with that. Okay, because I think you guys added phones the day before last year. So I wrote the jankiest malware I've ever written for that. It was terrible. It was, I literally was scripting pixel presses in that malware by forwarding ADB over TCP/IP. It was terrible. And it only worked like half of the time, but it was what it was. And for having one day of prep time, I was pretty happy. But I learned a ton of stuff by hanging out in the Red Team room, some of the interesting things that other folks are doing, and that translated into a lot of interesting course development, particularly for authentication, because Red Team loves messing with auth, okay? Some of which made it directly into CSEC 472. When you get up to there is literally Red Team malware in the CSEC 472 slide decks, okay? So I joined the ISTS Red Team again this year, wanted to learn more, and my main goal is not to write janky malware this time. So to write something that would actually work. So how am I going to learn? So I got on the Red Team about 3 weeks earlier because I think my name got dropped off the list for some reason, or they figured I was a one-off. Red Team was strong. They already had a solid plan at this point. Most of it was focused on Linux. Didn't have a ton for Windows yet, and most of the Windows stuff was, we're going to do Cobalt Strike. And Cobalt Strike's cool, but we decided that we wanted some interesting persistence mechanisms that were custom and not just entirely rely on Cobalt Strike, because if you block Cobalt Strike beacons, it's kind of game over. All right? As the CCDC team, I think, has done a pretty good job at any CCDC. Also, I figured I probably should know a little bit more about MITRE's attack framework and how to actually make use of the knowledge inside of attacks framework. If you're not familiar with MITRE's attack framework, it is a standardized methodology for categorizing the tools, techniques, and practices of advanced persistent threats. So we're kind of running off the backs of giants here, okay? Because we're actually, MITRE's attack framework is aimed at looking at what, let's be frank, mostly nation states are doing out in the wild. And they've categorized this into 11 categories: initial access, execution, persistence, privilege escalation, notification. I'm going to mute this. I don't have any sound, so. Defense evasion, credential access, discovery, lateral movement, whatever. Anyway, so persistence is the one I wanted to focus on. Okay? Persistence was the one I wanted to focus on. Now, what's interesting about MITRE's attack framework is it gives you descriptions of techniques at a very high level. It does not, at a very hands-on level, tell you how to operationalize these techniques. It doesn't tell you, here's exactly what you need to do or the code that you need to write in order to get this technique to work. So it doesn't do all the work for you. you still have to figure stuff out on yourself, which I actually really like. Okay? And I've got a student looking at how we can, as his master's project, how we can use the MITRE ATT&CK framework and leverage it for pen testing. So the plan of attack. Haha. Yeah, you see what I did there. I'm going to look at the attack framework. I'm going to identify techniques that work for persistence. And I'm going to write some custom persistence tools for malware with reasonably little Windows systems programming experience. I've done some Windows systems programming before, and part of this was in prepping for CSEC 201. One of the ways we wanted to differentiate the new programming for information security class from the mechanics class was having Windows systems programming component, which better sets you up to do reversing in Windows environments, which is where a lot of the interesting malware is. So this kind of nicely, this goal nicely dovetailed with what I was doing with 201. So cool, okay, what am I actually going to do? What code am I going to write? So I sat down and said, I don't know, I'm just going to more or less throw some darts at this MITRE ATT&CK framework and try some stuff out and see what makes sense. And I went through a lot of different choices before ending up on settling on the techniques that I used. So technique number 1, Office application startup. Okay? And I literally just went to attack framework and clicked on a random thing in the persistence column. Good way to start. So I read through it. It's using Office template macros. Office macros have a long history of being used for malicious purposes. And option 2 is using DLLs that automatically get loaded when you open Office documents. A little bit more interesting, but it's not particularly reliable for ISTS because there's not a lot of Office in the ISTS environment. Additionally, it's been a while since I've worked with VBA. So could I do it? Probably. Is it going to be a headache? Sure. And chances are pretty good it's not going to be terribly effective. Hidden files and directories. Okay, cool. This is an interesting thing. I didn't know that Windows could do this, but there's no direct code execution. Why is this in the persistence category and not in the evasion category? Okay, it's just how do you hide stuff in Windows? Like, it helps with persistence maybe a little bit, but it doesn't actually get you persistence in the long run. It's a form of evading detection and evading analysis. Third, registry run keys. So there's some keys in the registry. I've got one here as an example, but there's 4 different registry keys that you can specify which run on boot. Okay? So this is a little bit more interesting, but I feel like this one's pretty easy to catch. Also, I'm not sure how much these VMs are going to be rebooted. Okay? But I feel like this is pretty low-hanging fruit that the blue teams would catch pretty easily. And it's a good thing. Red team typically wants blue team to catch some of this stuff easily during ISTS because it's a learning experience in addition to being a competition. So we want some low-hanging fruit, but the particular project I was working on was not aimed at being the low-hanging fruit. Okay? Option 4, app init DLLs. Cool. This looked really interesting. So you can specify in this particular registry key DLLs that get loaded anytime the user32 DLL file gets loaded. Windows user32 DLL get loaded by Windows all the time. Okay? Almost everything loads user32 DLL, which means this fires almost all the time. But it does fire a little bit janky because the particular registry setting that you have to set, there's differences between 64-bit and 32-bit operating systems, and it varies if you're also using 62-bit or 32-bit DLLs. So like you have to kind of pair things up really nicely, and it doesn't always work that cleanly. So it's a hair better, but it's not a perfect solution. The one that I really liked was this authentication package. It's basically the Windows version of a PAM module. How many people know what a PAM module is? Cool. Yeah, PAM modules are awesome. They're fantastic for red teaming because it basically just lets you drop in a backdoor that almost nobody actually sees because nobody inspects their PAM modules. So this would be a really, really effective persistence techniques, and it also kind of is the Windows version of what red team does on the Linux side too. We have our fun PAM modules that we like to use on Linux, on our Linux boxes. But in looking at how you do this, it's a really convoluted thing to do, and I want to do it, but I can't get it done in the time frame. So this is one of the things I'd really like to come back around and hit. Last dart thrown, app cert DLL. This fires anytime any of the create process functions are called, or winexec is called, or shell execute. I don't have that in there, but shell execute also triggers this. This means this also fires anytime the Windows user interface or the operating system calls any of these function calls, which pretty much guarantees you system access. It almost guarantees that your malware is going to run as root at some point, well, administrator at some point. On top of that, it also fires at boot, because Windows runs a bunch of binaries at boot. So at the very least, your malware is going to run, you can be guaranteed your malware is going to run as administrator at boot. So cool, this is what I'm going to do. This was my option. Okay, this is what I figured. Hello World DLL. So just a little bit of background as I dig into some of the code for how this works. If you haven't written a DLL before, Microsoft has some good tutorials. Basically, normally we have a main function, and what we have inside of actually, let me take a step back. We have some function that we write. We load the DLL, okay, and then we call functions that are inside of the DLL. So how does that work? We fetch a pointer. We fetch a pointer from inside this DLL to a function and make use of that function. As a function call. Okay. On the DLL side, we have some function that we are explicitly exporting, and as long as we have extern C decal spec DLL export at the top, things that load our DLL can fetch a pointer to this function. Okay, and then we can invoke this from this function from anything that has loaded our DLL. So it's a pretty cool thing. Basically, the advantage is that binaries can import already compiled code. The binaries don't have to have this compiled code in them. The binaries don't have to do static linking. Your binary becomes lighter weight, and but you still get the same set of functionalities as if you were using like header files. DLL structures. DLLs have a DLL main. Okay, that DLL main is where you put your main function as the entry point to a DLL, and then you can have whatever other functions you want inside your DLL besides DLL main. Okay, and going back, I can throw that extern C decal spec export precompiler directive in front of any function I want, and say this function is now available to anybody who loads my DLL. Oop, wow. How did I hop all the way to the end? Okay. So DLL main is our entry point. So my approach was I found some cool tutorials for how to do this. There was this guy, Benoit Stevens, I think his name was, who had a really cool tutorial that kind of got me started. Building a malicious DLL, making sure that I throw that decal spec DLL export out in front of DLL main to make sure DLL main is called. From there, all I have to do is move the malicious DLL onto the system, and in the registry, point some key in the appcert DLL registry entry to my malicious DLL. And the key name doesn't actually matter. So you can see here, for example, my key name is blah, blah, blah. Okay? So Windows will loop over everything in this registry entry and fire it. So just fire all the DLLs anytime any binary is run. Isn't Windows awesome? But there's a catch. There's a catch. And that is, Windows, when you run processes, has a lock. Okay, so whenever you call create process, this lock gets set. Okay, and the lock is set to make sure that Windows is only going through creating one process at a time. Now, interestingly, load library sets the same lock. So if I try to use create process in malware that is being triggered by load library, my create process function call is going to wait on the same lock that my load library function call already has. And I end up in a state of deadlock, which was awesome because having taught operating systems, deadlock is one of those things like, yeah, I've got to teach it, but it's super boring because you never encounter it out in the real world. hey, I countered it in the real world. And I bricked a bunch of VMs before I figured out what was going on. Because I would forget to delete my registry entry before rebooting my VM, and oops, now my VM is in deadlock on boot. So by the end of this, I got very good at making sure I was snapshotting things. All right, so what did I actually do with this? Let's start with adding user accounts. There's a library for that. All right, so taking a step back, what that means is I have to do all of my malicious activities in Windows without running a single process. So how can I do malicious things in Windows without creating a process? That's a hard problem, right? So let's look at what libraries are possible. So I started off trying to figure out how do I create a user. And it turns out there is a library for that. It's basically an API that makes use of the Windows internals that are behind net. It doesn't actually invoke net, interestingly. It doesn't invoke the net binary in System32, but it makes use of the same API internals, which is weird. I'd love to see how they do that behind the scenes. Like, I'd love to see the source code for this library. But it's pretty straightforward. All you do is you basically, I'm not going to go into the details of what all of this means, but you pretty much, you create a user account. You just set up a string for the name of the user account you want created. You have to fetch the domain. Depending on if you want it to be a local user or a domain user, you have to either fetch the domain or specify the name of the computer for where you want that to be. You specify what password you want sent, and you hit go. Okay? You can also specify the privilege level of the user account to be created here too. So what I'm doing in this section of code is I'm creating a user called Colonel Sanders with a password Hakuna Matata 1 exclamation mark exclamation mark. Creating that user and then adding that user to the two groups, to the two local groups, administrators and remote desktop users. So Colonel Sanders was always a local admin. Okay? Which also meant that I got a new user account every time you ran any binary. Yeah, it's fun. Man, what is going on with this? Okay, RDP. We wanted RDP on. Hey, it turns out after a little bit of research, remote desktop really wants to be on in Windows. Okay, it sits there. I didn't know this. It sits there pretty much polling a registry value, and if the registry value switches from 0 to 1, remote desktop just snaps on. Yep. So again, static file manipulation, right? All I'm doing is changing a value in the registry. No process created. Okay. So here's just a section of code for in C manipulating, or actually C++, for turning on the registry, or turning on that particular value in the registry. Changing the desktop background. This one was a little bit more interesting, took a little bit of research, but there is a function call for the system preferences. It's a wrapper for some kind of Windows API for system preferences, where you can just specify a file path to an image, and it changes the background. So again, no process needing to be created. Enabling Windows RM. We wanted to make sure that you couldn't just disable all that the blue teams couldn't just disable all the external services and lock us out that way. Okay, so yeah, we could always get in with RDP, but we want to make sure you wouldn't just like turn off SMB, turn off WinRM, and now we can't actually get any code execution. So this one, I don't know if I ever actually fully got this working, because enabling WinRM, it turns out, is really hard, because there's a service that you have to set up, and not only do you have to set up the service, but you also have to set a bunch of values that the service needs to run, such as setting up the IP addresses that the WinRM service is going to be listening on. So that's what this is like, and you can see from my comments, like, take care of group policy, I hope. I'm not sure if I ever actually got this fully working. So if any blue teams in the room know whether or not WinRM kept turning back on, let me know. I'm very interested. But this was a little bit messy. But as you can see, all I was doing was, again, registry entries, right? So this was a bit of a problem. Turning off the firewall. Turning off the firewall. There's, again, this code is cut and paste from Microsoft's website. Yes. What?
Turning off the firewall disables WinRM.
Oh, interesting.
So WinRM will stop working the firewalls off. So it's probably your issue, and I know this is the exact same thing happened to us at a red team meeting.
Cool. That's good. That's good to know. That's good to know. So Jamie Geiger was trying to get me to go through, not just drop the firewall, but to go through and like change port by port. That probably would have solved that problem. Okay, cool. That makes a lot of sense. Okay, so how do you turn off the firewall? You follow Microsoft's tutorial for how to turn off the firewall programmatically. Like I said, I literally copied and pasted this from a Microsoft tutorial, which, by the way, if you look at the second image on the right, you'll see go to, which I think I'm interpreting that as Microsoft officially endorsing spaghetti code. But broadly speaking, how does this work? Basically, there is this thing, this object called inetfw policy 2. You fetch a pointer to the firewall policy, and then all you do is, with the pointer to the firewall policy, all you do is you go in and turn it off. And again, all this happens without any processes being invoked, which I think is the really interesting thing. How do we deploy this? Ansible, good old Ansible. A few scripts, drop Sanders DLL, so we moved our Sanders DLL into syswow 64 vscript.dll. Sounds totally innocuous, right? And then we would drop the background image somewhere. We called it button.jpg. I don't think anybody actually found this, which would have been actually good. You could have really, if you had found the DLLs, you could have really done some interesting stuff with them. And then all we have to do is add a registry entry, which, again, there's an Ansible module for that. So you can see this time around, I'm creating a registry entry in the correct path. The name of the registry entry is this is bad, and the data for that particular registry entry is the file path for my DLL, and the type is string. Over on the right, you can see this actually running. One of my takeaways from this was don't use Ansible for deployment because it takes forever. Like it would take, for running it against all 12 teams? 11 teams? 13. All 13 teams, it took us like 8 to 10 minutes. So that was a little bit weightier, and I'm probably going to do something different. So my big takeaways from this particular project and from ISTS this year, learning a lot more about coding DLLs, which caused me to scrap my initial plan for Lab 6 of CSEC 201. I learned a lot more about Windows internals, became a lot more comfortable working with Windows registry and doing interesting things with registry, and also changed my opinion about Windows a little bit. The more I work with Windows, the more I come to realize how good its perimeter security is, in that pretty much you're not getting in if it's up to date, if the authentication mechanisms are reliable. In other words, it's not like using old NTLM hashing mechanisms or old versions of SMB. And getting credentials, like those are your 3 ways in. And if those 3 ways are all defended, you're not breaking the domain. But once you do get past the perimeter, it is full of soft, squishy targets for post-exploitation hijinks. Some future work, enabling the user account. So this was how most of the teams, and I see some people in the room nodding at this, how most of the teams ended up blocking Colonel Sanders. They didn't delete the user account because it turns out if you delete the user account, net user will create the user account. Net, invoking the net binary at the command line, causes my malware to fire. So if you run net user delete, it actually adds my user account in, okay? Which I think some teams discovered, and they just disabled it in an Active Directory, which is a good call, and now I need to learn more about the Net32 API in order to figure out how to enable user accounts. I really should have thought of that. I noticed this, helping out a blue team whose System32 binaries got bricked, which was not red team. I'm still a little bit salty about that. Because that broke like a significant portion of, that particular thing broke a significant portion of the red team's Windows junk, our malware. Adding persistent staging. So there's a lot of techniques that are really, really similar to this. For example, there's a different registry entry that fires anytime netsh is invoked. You can just specify DLLs, and anytime netsh is invoked, it runs all these DLLs. So if you ever saw the Sauron user account get fired, that's where Sauron came from. Adding operational security. If you found my DLL and reversed my DLL, it just ran strings on it even, you could see that you could find my Colonel Sanders user account and the Colonel Sanders password just by running strings on this DLL. You would also find some, let's just call them colorful comments that I left in my code when I was a little bit frustrated, which, by the way, let me just plug for PowerPoint 2019. It has hand drawing on PowerPoint slides now, which include like sparkly galaxy graphics. It's awesome. It's fantastic. I thought that appropriate for, again, my colorful comments. Adding operational security, of course, and scripting deployment with WinRM directly, not using Ansible and or WMI. Yeah. So questions? If not, I have a we can do a quick demo too. Yeah.
Would turning on DLL checking with us built in DLL checking detect the DLL?
That's a good question. So I'm not actually injecting it. Okay? Yeah, but that's a good question. I don't know the answer to that. So try it and let me know. Okay? Otherwise, let me just kind of show you what this looks like on my end. So let me hop over to here. So we have the registry open. We have this appcert DLLs, which this is not here by default. So if I just delete it, I go add new key, and I call this appcert DLL. I've got one too many L's in there. Rename. Okay, and I go new string value. Why is this a feature? And we'll set the value. I currently have the DLL sitting on the desktop, so I'll just have c:/users/administrator desktop bleach.dll, which was my code name for the project. Okay, cool. Set. We're good. If we see here net users, no user or anything, desktop is normal. Let's go open up Internet Explorer. Uh-oh. We got a problem. If I run net users, oop, there's Haxor. Net user, Haxor, delete. Uh-oh. So you can clear this out without changing the registry, but interestingly, you have to go through the control panel. That was one of my interesting takeaways, is that apparently the control panel, all the control panel management techniques make use of the Windows APIs rather than running the binaries in System32. Yeah, they're not EXEs. So cool, this is an interesting case where your command line kung fu does not help you.
What happens if the path that's in the registry value points to path that doesn't exist?
Nothing.
Nothing?
Nothing. Yep, so let's just do this real quick. Yeah, absolutely nothing. Oop. So foobar. Okay. Close Internet Explorer. Nothing. Yep. So it's totally silent. Other questions? Any other questions particularly from the ISTS blue teams? All right. In that case, I will end this with, let's say long reign Colonel Sanders, the glorious leader of Pakistan.